Hi guys, so we will complete what we started in the last video. So what we are doing is doing the pre-processing to medical imaging but in volumes. So what we did in the last video, which we will do just a summary. We created the paths of each patient for the training and validation, and we created a dictionary that will have two columns. The first column will be the images, the second one will be the labels, and each column will get multiple rows for depending to the number of patients that you got. Then here are the basic transforms that we just applied, which loading the image, adding a channel for the batch size, and converting the final image into tensors. Then here what we did, the data loader, we loaded the data with its transformation. Now what we will do, we will pick one patient and we will apply this, but you will not see any difference because we didn't do anything. We just loaded the image, added the channel. It will do, we will see any difference. It will be like the same thing here. So what we will do, just to see if our functions are working, what we will do, we pick, as I told you, pick one patient and we will print and we will plot one slice of it. So to do this, like here I can do any, like the first patient, like here, test patient here. So to pick one patient, there is a function in Monai as well called first. So this function first, it will pick the first patient or the first array from the data loader. So we need to include it here. You can do something else, but this one is easy and it will work very fast. So here we'll import this first from Monai utils that import first, like this. Okay, run it again to not have a problem. Now here the first passing, which is first, like this. Then here what we will put the data loader, which is, if we want to see one of the training, we will put the training loader or validation loader or anything. So what we will do here, we have train loader. Okay, that's it. Now what we have, this value is a problem here, maybe we see about it. Okay, we see about it. So after some research, I found the problem, which is a very stupid problem from me. You can see here that this big error is just for saying that there is some problems in the keys of here. Where is it? There is problems in the keys while applying. Where is here? Yeah, there is problem with the keys where applying this transforms in our image, which is, here is my problem. Here is, I am putting, instead of label, I am putting labels. You can see that is very stupid error, but you can see that something very easy, very stupid can make a problem for you. So now here we have label instead of labels, and I am sorry for this mistake. So here is our transforms, and we will load this again, and now we will see that there is no problem with this first patient. Now what we will do, we'll just print one, we'll plot one patient to see what is happening after doing this simple transforms. So to do this, we will use the matplotlib. So here from matplotlib dot pyplot, like this, not from, but import as plt, like this. Okay, run it again. Now what we will do is just to create some figures, then plot the slices on them. So here we have the first plt dot figure, like this. Maybe I will give it a name like test, why not, like just for testing or printing or anything you want to give it a name. Then here for the windows I will put it 12 by 6. Okay, now what we will create will what I want to do is just to print to plot one slice of the patient and its label. So we'll divide or subplot the image or the figure that we have into two parts, one for the image and second one for the label. We'll add another one after, but after applying the transforms. But now I will just apply I will just plot these two images. So here we have plt dot subplot. Then as I told you, we want one line and two columns. So 1 comma 2 means that we'll divide the figure into 1 then 2. I know that you know that, but just I am talking about it now. Here we have 1 for the first part of these two parts that we have created or we have divided. I want this, for example. Now what we will do, we'll create a title for the first part. So here we have plt.title. Then here I will put like slice of a patient. Why not? You can put anything you want here. Then the same thing for the, and now we, of course we'll plot plt.imshow here. Now what we need to do in this imshow, we need to put the slice, which is one slice of our patient. Now I don't know if we talked about this before, but as I told you here, the first patient will be, if I will print it here, you can see here we have the image and its values, which are between -3000 and 1000 something, but it differs from each patient, but most of them have the minimum value is -3000, etc. But we don't need them for now. And you can see here we have the key image, and we'll get, I don't know if you can see, we cannot see it here, but we have another key, which is the, I don't want to open this here, but it will be a lot, but we'll have another key, which is label and its values. Okay, I will delete. Now you know that we will have two types of data, one for the image or one of the data, and the other one for the label. So using dictionaries, if you have never used it before, if you have used it before, you don't need to know what I will say now. But if you want to talk about the data or the image, so you can put train loader, but not here, because train loader will have all the images, but we can talk only about this one. For example, here like print and test patient. Here is the test patient, contains the image and label. But if we want to talk only about the image, so you can put the key here, image. So image means that you are talking only about the image. We'll print it here, and you will see here is there is only 10 steps. There is no the keyword image because we are already printing the image. And the same thing here for the label. We'll see the values of the label, zeros and ones and etc. It have to be 0 and 1. In my case there is multiple classes, so there is other values, but we will not talk about this now. But here is what we will do. We are talking about if we have only two classes, background and the tumor, for example. So in this case, here is how you do how to print only the labels. And the other one, if you want to print the image, you can put here, instead of label, you print the image. Okay, now we know how can we call the image and how can we call the label. Now what we'll do, we will plot the image, then we will plot the label. To talk about the image, what we can do here, we have the test patient. Now in the test patient, we'll call the image because we are talking about the image. Then, as I told you, we want to plot only one slice, so we need to call this slice. So to do this, here we have, so now what we have to do, we have to define one slice. Okay, so now I will talk about something else. Here what we have to do, as I told you before, we have to have only 4 dimensions. Like here we have the width, and the height and the number of slices. But as we said, we added another dimension which is for the batch size, so we can call it, for example, B for batch size, like this. So here we have the batch size, the width, the height, and the slice. But in our case here, what we are doing image segmentation. So if we have only two classes like background and foreground, which is the tumor, so here we need to define which slice we are talking, which channel we are talking about. We are talking about the foreground or the background. We say that here we are talking about the image. Why I am talking about this? But actually, you are right. We need another dimension to define the foreground or the background, but we don't need it in the image. We need it in the label, and we will get it in the prediction label, but we don't need it in the image. But because we are doing some mathematical operations, so we need to have the same dimensions for all the arrays or for all the tensors. So the image tensor should have the same dimensions as the label tensor, and the same dimensions as the predicted mask that you will get after doing the training. So here I will call it, for example, the C for channel, or for the foreground or the background. Okay, but this one, don't worry about it, because you will not do it manually. When it will load data, it will create a new channel here for the foreground and the background. Now, you know that, as I told you here, the first one is for the batch, the second one is for the channel, which is the foreground or the background, and these are for the width and the height. Okay, now for the batch size we have only one. Okay, so the index of the first item from an array is 0, because we start always by 0. If I will put 1, it will give us an error, because 1 means that the second item, but we know that we have only one batch size, so we should put 0. The same thing here in the image, we should put 0, means that we are talking about, we don't have because in the images we don't have multiple channels, so we have only one channel with the index 0. Now for the width and the height and for the slice, the width will take the whole width, so we can put 2 comma semicolon. The column here means that all the width, all the pixels of the width, and the same thing for the height. Now for the slice, we need to specify one slice. So for example, I will give it slice 30 or 40 or anything between 0 and 127, because we have 128 slices in my case. It depends to your data. Okay, now we have the batch size, the number of the number of channel, but we don't need it for now, and width, height, and the number of slice. Okay, but now we know that in medical imaging we have the images in the grayscale space, so we need to specify this so that it will be more clear. We can skip this parameter, but the output that we will see, it will not be visible, so you can add this CMAP, and you can put here gray for the grayscale, so it will show us the images at or the slice at great vision, not great vision but clear vision. Okay, now what we have to do, we need to define the second subplot, which will have the label. So we have blt dot subplot like this. Now the same thing, 1, then 2, then 2, means that one line or one row, 2 columns, the second part, because we divided into 2. The first part is here, we put the image. The second part we will put the label like this. Then we will do the same thing here, blt dot title like this, and in the title we will put here, like for example, slice, or we can put label of a patient like this, which will be the same label of the same patient, because here we are taking the first patient from the data loader, then we divided it into image and label. Now I will just copy this here. Now we are talking about only the or because we will talk here about the label like this, the same dimensions, but now the labels is not like the image, because the image is like grayscale. It will differentiate between each pixel to see if to see the different parts of the human body. But the labels are only zeros and ones. There is no variations between 0 and 1, so we don't need this. I will just take it. We can leave it, but we don't need it here for the label. We need it only for the image. Okay. Then after doing all these, we'll do plt dot show. Okay. Now we will see what we will get. I will put this here. Okay, so as I told you, now we didn't do any pre-process, so the image is at the same thing as the beginning here. We can see that the image is rotated a little bit, but it is just for printing. But if we will save this image, it will be at the same direction as this, so don't worry about it. Just here to plot it, we can see it here, but it is good way, I think, to plot this kind of shapes. Okay, but don't worry about it. Everything is in its place, because if this image is rotated, the same thing for the label will be rotated with it, so don't worry about it. Now here you can see this is the image without any pre-process. We just loaded the image, added a channel, and converted it into a tensor. Now if you want to apply something, that we will do, maybe we'll clear this this white stuff that we don't need, so which means we change the contrast of our image. And here now we will start doing the pre-process. But before doing this, there is something that I want to talk about. We know that in images, normal images, 2D images, there is pixels, and here we have voxels, because we have 3D or images with depth, or each slice has the width, or each pixel has the width and height and depth. So when we have a depth, we talk about voxel, which means a box, not a 2D square. So when we have a data set of patients, we are not sure if all the patients have the same dimensions, which means we don't know if each voxel for all the images or for all the patients has the same dimensions. The same thing when we are doing something like classification of cat and dog. When we have when we have images in the input, we don't take them just like this and put them to the model. We'll get a problem, of course, but we need always to do a resize in the input. In the pre-process, there is always a resize, so that if we have multiple dimensions of the images, we will always resize them into one dimensions, unique dimensions for the model, either in the training or in the testing or anything. In the 2D images, we do always this resize, and the same thing here in the medical images. We need to do always this pixels or voxels normalization. So we need always to give one specific dimensions for all the voxels that we will get in the input. So here, sorry, I'm talking a lot, but I am trying to explain all the problems that I got in my internship, so that any one of you will not get it in his future work. So we will add this function. There is a function called spacing d, which is always, we have d for dictionary. So this spacing d will control this spacing, because I think you have already heard about this word spacing, because if you take a DICOM image and you would visualize the informations that we got in this image, because we know a DICOM image, there is the pixel array, which contains the pixels and its values, and there are other informations which are the values of the dimensions, and there is this spacing word which talks about the voxel values with height and depth. So there is a function with this name in Monai that we will use. But before doing this, I want just to do something. We have here train transform. I will just create a copy of it, so that we will keep the function, or we will keep the image without any pre-process, and we will create another one that will have the pre-process, so that we will see the difference. So here, maybe this one, I will call it original, like original, I will leave it transform, like original image. Then this one will be the transform that we will apply for the training, and this one for the validation. Okay, now as you can see here, we'll change the others at the next step. Now we will try to apply some transformations. Here what we have, as I told you, there is the spacing function. I will add it here, spacing D, like this. This spacing D function will help us to change the spacing. I will run it, do not forget it after. Now here, as I told you, spacing D, here is the function. Now what we will do, we'll apply the this normalization to the voxels. The same thing here for the image and for the label, because if we will apply it into only the image, so the labels will not be at the same positions at first. So maybe the tumors will not be segmented directly, because if you will change because here when we do this, like we are changing some dimensions in the image. So if you have the image and label, then you resize, like imagine with me, you resize the image and you don't resize the label, so the position of the tumor will change here, and we will not do it actually because you have two different dimensions, so it will not work. So what we will do, the keys here, the first parameter here, the keys like image and label, because I told you we want to apply them to both of them. Then there is the other parameter, which is pixdim, which is pixel dimension. Now we will specify 1 pixel or 3 pixel dimensions, which are the width, height, and the depth. So when I was doing this with Monai, when I saw their tutorial, I found them using a unique value, which is 1.5 for the width and 1.5 for the height and 2 for the depth, and I used it and it was okay for me. So for that I will leave it here. If you want to change it, you can change it. Okay, and I verified my data actually, and I found that there are some patients that has 2 here for the width and height. There are others that have 5 in the width and height, which means that there is no specific number for all of them. For that, you need to use this function, which will make for all the patients the same dimension, so you will not get any problem after. Now, this is the first thing that we will do, the preprocess to make the values unique. If I will run this, I will show you that you will not see any difference. But why don't I create a data loader for original images, so we can see always from now here, and like original data sets, original. This copy and paste way is not the best, but here we will use the original transforms. The same thing here, original. So we'll get this one with this loader will load the original transform, the same data, same training data, but it will apply this original transform, which means that it will just load it at the channel to and convert it into PyTorch tensor, so that just when we will apply some transformations, we can see the difference. Okay, now for that I need to create a new. Here we have 3, then here we have 2. Why I'm doing this? Here 3, then 3, the same thing here. Why? Because this is the second. I want to put the first subplot that I want it to be the original image. So here I will put original, like original patient. And here I need to create a new one, like original patient equal first, then original loader, like this. So now I will take one patient from the data loader of the original images without any transforms. Remember with me this. Then here what I will do, the same thing. original patient. So now what we will do, here we have the original patient. What we have to do, I will just to I will run this again. Now we have two patients. This test patient is the patient that have been applied for these transforms, but you can see that now what we did, we just changed this the dimensions of the pixel, but you will see that there is something that I forgot, which is 1, 2, 1, 3, yeah, this one because the first one, sorry about that. Now here we have the original, here we have the slice image which have been applied, which we applied this dimension, then of course the label, but you can see that there is no difference between them, just a little bit, but we cannot talk about this small difference because we didn't do anything, we just changed the pixel dimension. But you can see that here the values, or yes, you can see here that the values of the dimensions of the image are changed. Here you can see that the values are from 0 into 512, and this one are from 0 into 256 or something. I didn't print them, but you can see, or 300 something, but you can see that the dimensions are changed. Why? Because we applied the function that will change the dimensions. So maybe the first dimensions were 3 or 4 for the width and 4 for the height. So when we applied this 1.2, like we divided the width and the height by 2. For that we see that the dimensions are smaller than these ones. Okay, so for that you need to apply them for the image and for the label. If you apply them only on the image, so the label will be 0 we'll have the width of 512, but for the image will be 256 or something. For that you have to pay attention with this. Now we will start doing some pre-processing that will do some changes in the image. The first thing that I want to recommend you to do is to change the contrast so that the image will be very clear. So here there is a function called scale intensity range, but then D for the dimension, for the directory, but dictionary, sorry. So this function I will write it, then I will explain after. So here we have scale. I need to add it here. Scale, then intensity range D. I think like this. I forget E here. Then this function scale intensity range, then here we have this D for the dictionary. This function will help us to change the contrast. I will write it then in scale intensity range D, then here. The keys, here we need to know about it. What we will do, we will scale the intensity of the image. So which means that we will scale only this image. We don't need to scale this. For that, here we will apply the keyword or the key for the dictionary only for the image, which means apply this transform only on the image, don't apply it in the label. So here what we need to do is just write here image, like apply this transform or apply this scaling of the intensity only on the image, don't apply it in the label. Okay, so now what we have to do is to add some parameters. I will add them, then I will talk about them because there is something I want to say about this. Minimum equal 200, maybe a max equal 200, then b minimum equal 0, then b minimum equal 1. Okay, we can leave this. If you want to apply them at the validation, I will just take these. You can do it. We are just testing, but you can apply them because this type of pre-processing, you need to apply them in the training and in the validation. Of course, there are maybe some things that you will need for the data augmentation, you can apply them only in the training, but we will not talk about them in this video. But here what we are doing the pre-process. So here you will talk about what is these values. So I will answer you. Before that, I will just go here below, not this. Here I have this. Below I will create new cell. What I will do, I will print the value of the values of the pixels. As if you remember with me, it was like 3000 minus 3000 for the minimum, and for the maximum it was like 1600. But we will do it now. Print. Here we have torch, which is the PyTorch function. Then here we have min for minimum. Then now what we will do, here we have the original or the test image. For now they have the same values, so we can put test patient, but the keyword image, because we are not talking about the mask or label. We need them, we don't need them now. So we have the minimum and the maximum. Okay, now you can see that the minimum is minus 3000 and the maximum is 1200, 900, etc. And for other patients there is minus 3000 into plus 3000, etc. But now that's what we have for this specific patient. But you will tell me what you are talking about, why we are having these values and these 0 and 1, etc. Don't worry about this, I will tell you. Now here the 300, because we had that minus 3000 for the contrast. For that the contrast is dense and we cannot see clearly the organs. So if we will decrease that value, which are, because here we have a min and a max, means that the values or the initial values of the contrast from the image. So you may ask me, why why I didn't put minus 3000 and here I need minus, why I didn't put minus 3000 and plus 100. Yes, if I did this, I will scale the intensity, but the contrast will be always at this, will not be visible. But what will happen, the values of the pixels, instead of having minus 3000 into 1900 something, we will get values between 0 and 1, which means we will normalize the values for, because if we want to do deep learning, we need always to have values between 0 and 1, so that the process will be faster. Because if we let the values between, here also minus, because if we let the values with minus 3000 and plus 3000, imagine with me how much time it will, how long it will take to do this calculation only for one patient. It will take forever. Okay, for that we need always to normalize them between 0 and 1. But here is 0 and 1. Okay, we accept that. But here if we leave minus 3000 and 1900, we will get the values between 0 and 1, but the contrast, which means the visibility, will be always like this. But this is not what we want. We want something very clear. For that I am using this minus 200 and 200. But where did I get these values? I will tell you there is a little trick that I used here in this ETK snap. So what you can do, you can download this software. It is free. Then you load one of your volumes, like what I did here. For example, you can just do this, load as main. Sorry, this is not an image, this was a label. So load this. Yes. So here is my patient, like this. Now if I will show you here tools, now you get here into color map editor or contrast, then you click in contrast adjustment, the same thing. You can see here these are our value. This is the minimum that we printed in Python, minus 3000, and here is the maximum value, which is 1900, sorry. And it will be different, it will differentiate between with the other patients. But now you can see that these values are giving us this contrast. If we will change them, like changing here or something like this, you can see that we will get more visibility. So if we will we'll change these values, something will change here. What I will do, but I will give you these values because that's what I was trying to do by myself after a lot of experiences with this software. But you can use by yourself. You can change and change and change until you get the value that you want. But I think these values will work for you exactly. What I did, I put here 0 and here 400, or I think I changed them. No, here 0 and here 400. Now you can see the minimum value I replaced it by 0 and the maximum value I replaced by 400. Like when you change these values, like if you play with, as you can see, I was playing with this before. So while playing with these, you will get something visible. So when you get something visible, like I will just reset it. 0, 400. So when you get something visible like this, or maybe you need something better than this one. So when you get something visible for you, you take these values. So from here I took minus 200 and 200. Okay, so these minus 200 and 200 are the new values. Instead putting, because when you want to normalize a vector or a matrix, what you will do, you have the maximum value and the minimum value, and you do that equation to calculate to convert the maximum value into 1 and the minimum value into 0, and between them you do the equation to calculate each value for the depending value. For example, for 1000 it will be like, for example, I don't know, 0.5 or 0.6. You know about this, I will not talk about it now, but that's what I did. Instead of getting minus 3000 and 1200, I took these values because when I did this changing in this window and level, I had these values. So now here is A, which means because we will go from A into B. So A minimum is minus 200, A maximum 200, and B minimum 0, B maximum is 1. Okay, now we'll see what I applied it here as well. So now we will see what will happen. There is something keyword inspected. B max like this. A mean A max, B mean B max. Here as well. Intensity ranged, I have already did it. I hope I run it. Maybe I forget. I always forget to run the updated cell. So now it is okay, you can see. Now we will see what will happen. In our Python repository. Are not seeing the difference. Why? There is something missing. Master B mean B max, I mean A max. The original files 3D. Yeah, here I forget one parameter, another parameter, sorry about that. And here you have to put them as float, so 0.0 and 1.0, and the same thing here. We have a parameter which is clip. We should put it true like this, and the same thing here. I will just copy it. And 0.0, 1.0, because we will convert them into values between 0 and 1 and not 0 and 1. So if we want values between 0 and 1, so they should be floats. Okay, sorry about all these mistakes, because when I do a long video, always I forget some stuff. So this one. Now we can see this difference that we were saying here. So you can see here we just deleted all this stuff that we don't need, and the organs are a little bit clear. So this was an example like minus 200 and 200. It worked for me well, because sometimes for other patients it is okay. So you need to find the best values for you by using this software if you want, or if you have another way to do this, you can use it as well. But for me, I used that ETK snap and it worked okay. Now here are the new pre-processed patients. For now, you can use this directly, you don't need anything else, but there are a lot of transformations that you can do. You can find them all in the documentation, but for me, at first, this was okay for me. It worked without any problem. There is another transformation that I will tell you about, and it will be the last, and sorry about this long video. So this transformation is to help you to not, because you can see that all this black area, we don't need it. So you can use some mathematical like NumPy or PyTorch to do this manually with for loop or something. But in Monai as well, there is a function that will do this work for you. It will delete all these parts that you don't need, and it will leave only the region of interest. But here we see that we have this white stuff, so maybe it will stop here. But for others, maybe it will take all this off because you don't need it. So that will help you to get to have smaller data. So let's go here. This function is called crop foreground. So this crop foreground, it will crop only the foreground, which is this one. This is the foreground, and we don't need all this parts. To do this, we need just to include it here. Crop foreground, and of course we need to add D for dictionary. Okay, so now I will run it to not forget it. We'll go to this after applying this transform. So now we will do crop foreground D, this one. So this function, of course, we need to give it the two keys for the image and for the label, so that it will crop both of them. Because if we will crop only the image, so what will happen for the label, of course. So what we will do is just here keys. Then of course we have the image, then the label. Okay, then there is something, because we will give it both of them, but the this function doesn't know which one is the image and which one is label. As human, we know, because we know that image in the dictionary we give it the name image, and for the label etc. But this function, or this function doesn't know, because if it knew, we don't have to give them these keys. So we need to specify which one is the image and which one is the label. Why we need to do this? Because here, if you do this, if it will go like searching for the region of interest or for the foreground from the label, so it will take only this region, because this is the only region that contains something. The other one is all zeros, and zeros is black background. But we don't need that. We need it to take the region of interest or the foreground from the image. So we need to say that starting from the image, do this crop. So here there is another parameter. Where is it? Here there is another parameter called the source key, which is this source key, which means in which key there is the image actually. So in which image or which data you want that function to do the crop. So we said that we want to take the foreground or the region of interest from the image. So the source key will be the image here. Okay, so remember with me, you need to give it the image. If you will give it the label, it will do the crop here, and you will not get anything from the image. So you have to specify here the image. Okay, now we'll see what will happen. Okay, now you see here we have all this stuff. Now as you can see, we have cropped the image. We took all the regions that we didn't want. I told you about this because we had that white line that for the program we see it like a region of interest, so it cannot crop it. It will stop here, but not bad. We just deleted all that part that we had here. For example, all these parts we just deleted, and the same thing for other patients. If for other patients there is no this white line, so it will crop it until here. So you can see that it is useful. Now what you can do, because this is another problem, if you will use this foreground, if you will not use the foreground image, you will get images with 256 like what we had after applying the changing of the dimensions. You remember that? Then if you will apply this foreground, you will get for each patient specific dimensions, because for each patient this region of interest differentiate. So for example, for one patient you will get 300, for another one you will get 200. So it depends to the region of interest of your patient. But if you will leave your patients like this, you will get of course errors, because each patient will have specific dimensions. So your model, your architecture and your model will not accept that, because it need to have the same dimensions for all the inputs. So if you will use this function, what you can do, you can add resize, like a normal resize of 2D images. There is a function here called resize D. So this function resize D will do the same thing as another image. We will use it here and I will show you. Here is, I will just define it, resize, and we should always add this D, which means for dictionary. So here, after, because we will apply this function, we load, add a channel, everything. Then we will do this crop. Now if we want to do the resize, we need to do it after the crop, not before it, because if we do it before it, we'll get always that problem. So here we have resize D, of course, and we need only 2 parameters. The first parameter is always the key, and here we will apply this resize into the image and the label, of course. I forget this label. Then the second parameter will be the new dimensions that we want, but here we are not in 2D images, we are in 3D volumes. So we have the parameter spatial size. So this spatial size will get the how do we call them? We'll get the value of the new width and the new height and the new number of slices. But for us, we will not resize the number of slices. So the number of slices will be always the same. I will leave it 128. But for the width and height, you can put them anything you want. For example, I will put them 128, and of course 28 for the width. This one you don't have to change it. It depends to how many slices you get. And of course, if you don't have the same number of slices for all your patients, you need to think about it, because you will get, of course, a problem. Because if you get for each patient not a specific number of slices, you cannot train your model. So think about this before. For me, I did this manually before doing the training. I created patients with the same number of slices. So maybe you can try this as well. So after doing this, now we get new data with the new dimensions. We'll see if it will work. Yeah. Here is the new image, like we did the crop and we resized it. You see that 128. So this is the image that you can use for your training data. This is an example, so you can put it 256 or anything you want to put it, you can try it. So this is the dimensions that I used for me, but it depends to you and your data. So we are now in the end of the video. I hope that it was helpful, and sorry about all the mistakes that I did. But as I told you, if I am doing a long video, I always do some of these mistakes. And you can see that to resume what we do, to yes, the summary of our work is always load the image, add a channel, and convert at the end the final result into a tensor. Here it depends to you. If you want to apply these, you can apply them. This is the basic pre-processing, and there are others in the documentation. You can see it if you want to apply something else, but if this is okay for you, so you can do it. And remember with me, this is only the pre-process without any data augmentation or anything else. We'll think to do another video about data augmentation using always this Monai Monai library, framework. So I hope that you enjoyed and it was helpful. Don't forget to subscribe to the channel if this video was helpful. Don't forget to do a thumbs up, and I see you in the next video. Bye bye.